pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA Unesa telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Insttitute Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999 melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan mandu pendidikan. Saat ini FMIPA Unesa memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti entrepreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science Unesa constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science Unesa must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science Unesa's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science Unesa continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk tercetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA Unesa memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA Unesa telah berdiri sejak tahun 1964 yang bermula dari fakultas. Saat ini FMIPA Unesa memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan masyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science Unesa constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science Unesa must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science Unesa currently employs 27 professors, 45 assistant professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science Unesa, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science Unesa community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science Unesa implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science Unesa is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science Unesa prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates Unesa's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science Unesa also facilitates the dissemination of science and technology development by managing scientific journals covered by Faculty of Mathematics and Natural Science Unesa are open access. Furthermore, Faculty of Mathematics and Natural Science Unesa is committed to the UNESCO-recommended open science movement.
Sini.
Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science Unesa's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science Unesa continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. Elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA Unesa memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA Unesa telah berdiri sejak tahun 1964. yang bermula dari Fakultas Keguruan Ilmu Eksakta, Insttitute Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA Unesa memiliki 16 program studi, yakni 10 program, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science Unesa constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science Unesa must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science Unesa currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science Unesa, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science Unesa community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science Unesa implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science Unesa is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science Unesa prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates Unesa's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science Unesa also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science Unesa are open access. Furthermore, Faculty of Mathematics and Natural Science Unesa is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science Unesa's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science Unesa continues to innovate to turn inspiration into achievement, producing bright graduates with environmental and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas dan berbasis riset sesuai dengan perkembangan zaman. FMIPA Unesa program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solid kehidupan bermasyarakat, berbangsa, dan berwawasan.
Achieve 3 pillars of higher education, as well as target and development in various fields. Products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Nature. Natural Science Unesa must achieve the three pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science Unesa currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science Unesa, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science Unesa community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science Unesa implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science Unesa is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science Unesa prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates Unesa's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science Unesa also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science Unesa are open access. Furthermore, Faculty of Mathematics and Natural Science Unesa is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science Unesa's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science Unesa continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the
afternoon, ladies
history
and
of the
gentlemen.
independence struggle
In
and
this
one of
beautiful
Indonesia's
moment,
metropolitan
I have some
cities,
notification
is
before
developing
we start
into
our
the
meeting
basis
today,
of creative
and
industry.
they refer to the general guidelines. Do you want
Enggak iki lho kok banyak interpelasi.
Thank you for the attention.
Surabaya, a
In
city
the next
associated
agenda,
with
we
the
will hear
history
the
of the
opening
independence
speech from
struggle
the
and
Vice
warmth
Dean
of
of
Indonesia's
Academic Affairs,
metropolitan
Student
cities,
Affairs and Alumni
is developing
of the
into the
Faculty
basis
of
of creative
Mathematics and Natural
industries and
Sciences,
a favorable site
Universitas
for
Negeri
exploring
Surabaya,
and advancing.
Professor Rosalina Ekawati, PhD. Prof. Rosalyn, time and screen is yours.
Apa-apa wis sakarep. Wis nang milih. Wis nang milih.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ladies and gentlemen,
Waalaikumsalam warahmatullahi
good afternoon. Honorable guest, Dean of the Faculty of Mathematics and Natural Sciences, Vice Dean, talented student, and the academic community gathered today to attend this public or this class. Even though this is Sunday, you are enthusiastic about attending this event. I really appreciate because we have a special guest for today. It is a great pleasure and honor that I stand before you to extend a warm welcome to Assistant Professor Choy Heng. Good afternoon, Professor. Prof. Choy is a highly respected scientist in the field of mathematics education and also STEM at National Institute of Education, Nanyang Technological University, Singapore. We are truly fortunate to have him here to share his insight on a topic nurturing the joy of learning through integrated STEM. Professor, we have here a bachelor student, master student, as well as doctoral student of our faculty. They are allowed to join this class. And in today's rapidly evolving landscape, we must explore innovative ways to instill the joy of learning in our students, and Professor Choi's expertise will explain this essential element of education. As we gather here today, let us open our heart and mind to the insight Professor Choy will share. Let us be inspired to foster a culture of curiosity, creativity, and a lifelong passion for learning in ourselves and future generations. Once again, Professor, I extend my warmest welcome to you. I look forward to enlightening and enriching lecture today. Thank you for your attention, and let us make the most of this exceptional opportunity to learn and grow together. Thank you, Professor, and all of you, the audience. Let's just follow the course, and I ask all of you to really join and post question if possible. And by this moment, I would like to open this public course. Bismillahirrahmanirrahim. The general lecture of Assistant Professor Choy Heng is open. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Rosalina Ekawati, PhD, for the warm welcome speech to us for today's general lecture and the support. Ladies and gentlemen, the following agenda is the photo session. I would like to inform you to stay on the screen, open the camera, and use the guest lecture virtual background. Again, please open the camera for all the participants. This photo session will start in 3, 2, 1. The second slide. 3, 2, 1. The third slide. 3, 2, 1. The next slide. 3, 2, 1. All the committed, is that enough? Okay, that's great. Thank you very much. Well, ladies and gentlemen, this is the end of our opening ceremony. Thank you for your participation. And ladies and gentlemen, we have come to our keynote speaker session. Our moderator, Bapak Dayat Hidayat, will moderate our presentation and discussion. He is the assistant professor in mathematics education at Universitas Negeri Surabaya. His expertise is in mathematical modeling in education, mathematics teacher development, and applied mathematics. He is also focused on STEM educational research. Pak Dayat, hello. How are
Yes,
you?
Bu Niswa, I'm here. Thank
Okay.
you.
Okay, are you ready to lead this session?
Yes, of course.
Okay, thank you, Pak Dayat. Time and screen are yours.
Okay, thank you very much, Bu Niswati. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Honorable Dean of Faculty of Mathematics and Natural Sciences, Professor Wasis MSE. Honorable Vice Dean 1 of Faculty, Professor Rosalina Ekawati PhD. Honorable Vice Dean 2 of Faculty, Dr. Siva Indana. Honorable Coordinator of Study Programs at Faculty, and Honorable Speaker today, Assistant Professor Choy Heng, and all distinguished participants of this session. First of all, I want to say thank you very much for joining our International Guest Lecture session by Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. Okay, ladies and gentlemen, I am Dayat Hidayat from Mathematics Education Study Program, the moderator of this guest lecture session. I'm very happy to see you here and welcome all of you to join this session. Our guest lecture session today is about nurturing the joy of learning through integrated STEM. It is an interesting topic this decade and is becoming increasingly important for today. And as well as our speaker today is already with us here, Assistant Professor Choy Heng. Hello, good afternoon, Professor.
Hello, good afternoon. Can you hear me?
Yeah, I can hear you crystal clear. Thank you, Professor. Okay, so thank you very much for your time. It is such an honor for us for having you here, and yeah, it's very honor for us. Thank you very much. Okay, ladies and gentlemen, first I'd like to read a brief introduction to our speaker. Yeah, operator, please. Okay, can you zoom out the But yeah, okay, thank you. Okay, ladies and gentlemen, and all participants, Assistant Professor Choy Ban Heng is Assistant Professor in Mathematics Education, National Institute of Education, Nanyang Technological University, Singapore. And he is actually also co-head for Multicentric Education, Research and Industry Center in NIE or Meristem at NIE. He obtained bachelor degrees and master degree program from Nanyang Technological University, Singapore, and obtained PhD degree from University of Auckland, New Zealand in 2015. Okay, and his award in 2020, he is awarded as excellent in teaching commendation at NIE, and in the same year, his team is awarded as Nexus Team Winner at NIE, and in 2013, he is awarded Early Career Award at Merga Conference in Melbourne. And his research focus are developing the expertise of mathematics teachers by using technology, planning predictive learning, and reviewing the improvement of students' mathematical reasoning. Moreover, he focused on enhancement of STEM education as an aspect of educational policies, initiatives, and practice that are aligned with goals. Okay, that's the brief introduction about you, Professor Choy. And without further ado, before the presentation start, let me tell you, all of you participants, how the presentation will go. So first, our speaker will be invited to present 1 hour explanation. And after that, there will be a question and answer session followed by a conclusion. Okay, so I think I cannot wait to hear your insightful presentation, Mr. Choi. So thank you very much. And without further ado, so now allow me to welcome the speaker, Assistant Professor Choy Ban Heng, to make his presentation. Okay, Professor Choy, are you ready, Professor?
Yes, I'm ready. I'm going to share my screen now.
Okay, thank you. Yeah, time is yours, Professor. Thank you.
Thank you, Professor Dayat, for the kind introduction. And thank you everyone for coming on this Sunday afternoon. I'm indeed honored to be part of this interesting lecture. And I hope you will have opportunities to learn some ideas, and I look forward to exchanging ideas with you and even, starting some form of questions towards the end of this session. I hope you can hear me loud and clear, and if not, just let me know through the chat. So why nurturing the joy of learning? I mean, that's a question that many of us ask, right? I mean, as teachers, what we are really interested in is to see our students enjoy learning, to see our students having that motivation to learn on their own, or even having that sparkle in their eyes that, at the end of a very hard day, it is all worthwhile. But very often, I think we sometimes hear complaints that our students are tired, they are not motivated, they sometimes don't see the reason why they and so here we are trying to think about how best to nurture the joy of learning, in our day-to-day teaching. So I'm going to just highlight some lessons that I personally learned as a mathematics educator. And I will start off with 2 stories. One from the past and one quite recent. And I will share with you 3 ideas or 3 frameworks of how integrated STEM might look like. And then I talk about the 4 phases of discipline and 5 things we can do as a teacher. So 2 stories, 3 frameworks, 4 phases, and 5 things we can do. So 2 stories. The first one is really a blast from the past. And the year was 2005. And I was a teacher in high school, dealing with interdisciplinary studies. I'm a mathematics teacher by training. I spent about 10 years teaching and in the high school, and my last portfolio as a high school teacher was the head of department of special projects. And as part of my role, I need to kind of design some programs to engage students in this interdisciplinary work. And one of the things that we started off is to kind of build a course around a problem. And the problem was about building a water-propelled rocket that can stay in the air for 15 seconds. And what happened was a team of us, 7 teachers from different disciplines. So I'm a mathematics teacher. We have a teacher from a subject called design and technology. We have teachers from the science department. We have teachers from even the humanities department and even the physical education department, all coming together to design this course. And as part of this course, we have to design a water rocket launcher. Now, in those days, internet wasn't very established yet. Google is not as good as now. And what we have to do is to figure out how to build our own water rocket launcher. There's a picture of this water rocket launcher. If you want to have a picture of it, that's how it looked like. And
Progress.
we came together and okay, I think there's a feedback somewhere. Okay, we came together and tried to build this, and I still remember the day that we managed to build the water rocket launcher. We tried so many times and we failed. But that very day, I remember we went to the middle of the field. 7 of us come together, put this small little launcher in the middle of the field. We put a water rocket, which is filled with water, and pump air through the rocket. And when we release the rocket, you can see the 7 of us saw the rocket flew up into the air. And at that moment, I saw many students in the school, all clustering around the windows and the corridors, and they were looking at us launching that rocket. And I remember the joy in their faces, and they were all saying, wow, and that was a moment to be remembered. So it was really my first integrated STEM experience, and it was fun. More recently, I have this privilege of working with 10 schools in Thailand, and that was part of a project funded by the Temasek Foundation in Singapore, where we work with the Office of Basic Education Commission in Thailand, and 10 schools spread all over Thailand. And as part of the project, we developed integrated STEM units with the schools. And one of the schools that I work with very closely is Uparaj Vidyalaya School, which is a high school located in Chiang Mai. And here what happened was they were designing some problems around the idea of water distribution. And in Thailand, unlike many of the modern cities, there are some parts of Thailand that are very remote. And because of that, water is always a problem. So the problem that the team of teachers had come up with was to design a water pipeline system for these remote villages. And as you can see, there's this very nice challenge problem. And immediately you can see that this is a complex problem that requires students to integrate different ideas from the different disciplines to solve this problem. And I'm just going to give you a few snapshots of what happened, and they kind of identify the problem in the beginning, spend some time even trying to get maybe, in touch with the problem, and that involves them, empathizing with the issues and looking at, the context of the problem. They try to understand the problem and define the problem and even research, how the water supply system can be created. And of course, after that, they kind of investigate, the pipeline system, and they look at the different aspects of a water supply system. For example, the size of the pipe, whether it's small or large, and how it affects the speed of water. They even look at the height of the tank. You need to store water somewhere, and you need to transport this water through the pipes. And they are looking at the relationships between the pipe size and the height of the tank. And you can see here, some the students are investigating, this problem using an approximation by doing some form of experiments. And also there's this idea that because it's remote and is situated in the actual part of Thailand, they use a Google map to kind of study the geological structure of the area around the villages. And of course, last but not least, they kind of think about the application of graph theory to solve this problem in terms of the pipeline system design. And so this whole thing culminate in solution ideation and solution making. They kind of have a briefing, and try to build a 3D model of how it might look like. And last but not least, they present their solutions and even describe how they are going to use this system. So here we see a few interesting observations, or we make a few interesting observations. One of which is this idea that the idea of real world working. Now, integrated STEM provides some opportunities for students to experience what is it like to work in the real world, but in a very safe environment. And you can see very clearly from the photographs, the students are highly engaged in 3 ways at least. One, they like it. They are engaged in an effective way. Number 2, throughout the lesson observations of the lessons, the students are actively involved in doing work. There's no behavioral problem. Number 3, they are cognitively engaged with the task. In fact, they spend quite a lot of time even thinking about the problem after the lesson. But last but not least, I think it offers opportunities for students to make connections. There are many opportunities to make what we call vertical connections within the same discipline, as well as connections across disciplines. So of course, the question is, how can we design such integrated STEM experiences? And here, I would like to share with you 3 frameworks that we have developed to kind of help us frame the design of such experiences. So the first one is really obvious. You realize that in both the water rocket as well as the water pipeline, there was a problem. There was a problem that is persistent. There's a problem that is multi-centric. There's a problem that invites people to want to solve them. And in the problem-centric STEM, what we are trying to do is to start with a problem. Use a problem to kind of help people see this same problem from the 4 disciplines: science, technology, engineering, and mathematics. And in this framework that we came up with, we use the process of problem solving as an overarching frame to connect the 4 disciplines. So you can clearly identify that, this steps almost looks like Korea's 4-step approach to solving problem. And this framework also serves as a way to kind of highlight the strength of the connections within and across the subject. So for example, when you see a thick line here, it suggests that there's a lot of opportunities for making inter-science connections. When you see a strong line between the two disciplines, it means, there's an opportunity to make strong connection between two disciplines. And when you see a dotted line, it means that, the connections are weak. Whatever the case may be, what this framework offers us is a way to start thinking about the design of a task that will allow us opportunities to make connections to other disciplines, and thereby creating experiences of a STEM learning. But that is not the only way to kind of frame an integrated STEM experience. Another way is to think of the solution-centric STEM. Now, in such a problem, we start off with a particular solution. And then from the solution, we learn different aspects of the solution based on our understanding of science, technology, mathematics, and engineering. And by understanding how the solution works and evaluate whether the solution is effective, we begin to formulate a second solution or even refine the solution. So it is by continuing thinking and refining the solution that we can get better and better solutions. And this actually happened also during the Thailand instance, because in the Thai project, what happened was the teacher showed a video of a water tank, which is an existing solution for one of the villages. And he was trying to make connections between what he was teaching about the Looney principle, which has to do with the flow of a liquid in the pipe, as well as the height and the location of the water tank. And here you can see how he kind of relate what the students saw in the video with the principle that he was trying to teach. And here you can begin to see opportunities for students to think about redesigning the existing pipe system for the problem that they are solving. But last but not least, the third framework that you can think of is really what we call the user-centric STEM. In a user-centric STEM, we are not looking at the problem. We are not looking at the solution, but we are looking at the user. Here, we see the user as the center that kind of pull together the different disciplines. So it is quite similar to the idea of design thinking in the sense that we empathize with the user. So we think about who are we designing the pipeline for? And what exactly is the problem? So here the problem is not predetermined. Instead, the problem is determined after we have interacted with the user. And here we kind of specify the context of use. We find out from the user what kind of problems they want us to solve, and thereby specifying the requirements before we produce the design solutions, evaluate the designs, and this process continues. And the idea of a human-centric or a user-centric approach is to humanize this subject called STEM. And to develop that empathy, it realized that it's actually not a natural thing for students. And in particular for the school that we were involved in, the students are living in the city. They might not understand fully what the situation might look like. And so one of the things that the teachers do is to engage the students in empathizing by watching videos. Of course, it would have been nice to bring the students to the actual site, but that might be too difficult. So at this point, I'm going to show you a quick video clip of a similar scenario. It is in Thai. We probably don't understand what they are saying, but you will get the idea of the problem just by looking at this video clip. So I'm going to stop my sharing for a while I get to the video clip. So just hold on for a while. Just do the video clip. Oh, okay. Okay, okay. So I'm going to go back to the Zoom, share my screen now. I hope you can see the clip. I think I need to share sound, so let me share sound.
ในพื้นที่ห่างไกลนะครับที่ระบบสาธารณูปโภคยังไม่ครบครันก็ทำให้ชาวบ้านที่อำเภอนาแห้วจังหวัดเลยพึ่งพาแหล่งน้ำตามธรรมชาตินะครับใช้ในชีวิตประจำวันแล้วก็ให้ความสำคัญครับกับการรักษาผืนป่าต้นน้ำให้คงสภาพสมบูรณ์ครับ
ค่ะเช้านี้จะพาคุณผู้ชมไปชมตัวอย่างหนึ่งที่เห็นได้อย่างชัดเจนคือที่หมู่บ้านแสงพาค่ะคุณออนซินีอมรบุรีจะพาคุณผู้ชมไปชมวิถีชีวิตของชาวบ้านที่นี่ที่ทุกครัวเรือนล้วนใช้น้ำจากประปาภูเขาทุกหยดด้วยความคุ้มค่าและก็ใช้ได้อย่างเกิดประโยชน์มากที่สุดค่ะ
รถอีต๊อกพาหนะคู่ใจชาวไร่บรรทุกกำลังคนพร้อมเครื่องมือเกษตรมุ่งหน้าไปยังที่หมายซึ่งอยู่ในป่าสูงไกลจากหมู่บ้านแสงพาออกไปอีกประมาณ5กิโลเมตรนี่เป็นอีกครั้งในรอบ1 เดือนที่ชายกลุ่มนี้รวมตัวกันทำภารกิจเพื่อคนทั้งหมู่บ้านสิ้นสุดทางรถพวกเขาต้องลงเดินต่อเบื้องหน้าคือต้นลำน้ำพาแหล่งกำเนิดประปาภูเขาที่คนแสงพากว่า200ครัวเรือนดื่มใช้
ในหมู่บ้านที่อยู่ห่างไกลกลางป่าเขาที่ระบบสาธารณูปโภคยังเข้าไม่ถึงการพึ่งพิงธรรมชาติจึงเป็นสิ่งที่ชาวหมู่บ้านแสงพาจำเป็นค่ะเพราะพวกเขาต้องดื่มและใช้น้ำจากภูเขารักษาป่าต้นน้ำที่หล่อเลี้ยงชีวิตคนแสงพามาหลายชั่วคนจึงเป็นสิ่งที่พวกเขาต้องดูแลให้ดีที่สุดค่ะ
กว่า1 ปีแล้วที่ลุงกวมวัย62 ปีเข้ามาเป็นกำลังหลักดูแลระบบประปาภูเขาร่วมกับเพื่อนวัยเดียวกันแลกกับค่าแรง500 บาทต่อเดือนนอกจากการทำความสะอาดโดยรอบแหล่งน้ำและดูแลหัวกะโหลกจ่ายน้ำไม่ให้เศษใบไม้อุดตันอีกภารกิจสำคัญคือการเดินตรวจท่อประปาตั้งแต่ด้านล่างจนถึงท่อจ่ายด้านบนภูเขารวมทั้งรีบซ่อมแซมจุดที่ชำรุดที่แม้เป็นเพียงจุดเล็กๆแต่ก็มีความหมายสำหรับคนทั้งหมู่บ้าน
แต่ละวันก็ต้องไปเที่ยวในบ้านนะเที่ยวในบ้านสำรวจดูว่าไอ้ท่อไหนก๊อกไหนที่มันชำรุดแล้วก็บอกเจ้าของเขาว่าก๊อกนี้มันรั่วมันชำรุดแล้วหาซื้อมาเปลี่ยนซะก็เดินสำรวจขึ้นมาเดินมาสำรวจตามสายท่อมาเดินมาถึงไหนที่มันเป็นจุดหมองนี้แถวนี้น่า
So I hope you kind of have a sense of the kind of activity that was shared with the students. Now let me get back to the slide. So the idea is to help the students identify the need and empathize with the user because they didn't have the chance to do so. They can't go to the place, but through the video and which is very real, they get a sense of the problems that they face. Of course, we do have some challenges. In fact, some of the lessons that we learn working with this includes things like it is really challenging to design and implement such STEM learning experiences. In fact, it requires a careful thought, careful planning, careful implementation, and even a review. And very often it is not about one teacher, because if you only have one teacher to do this, it's going to be very challenging. In fact, the team comprised of 7 teachers, and all 7 of them work very well together. And I was the consultant, I kind of help them to think about the integration part. And so it is really, while it's challenging, it is the team effort that allows the activity to be carried out. And here I would like to bring forth the idea of a Da Vinci team and not a Da Vinci teacher. Leonardo da Vinci is a very famous artist. I mean, he's best known for his painting Mona Lisa. But if you know Da Vinci,
Recording stopped.
he is also a scientist. He's also a mathematician, and he's also a designer. And so he's very good in everything. He's good in mathematics, science, design, and even technology at his time. But it's very difficult to find a teacher who is good in everything. But it is easy to find a team that is good in everything. So you comprise a team with different strengths, and when they come together, we could actually make all these integrated STEM experiences come alive. And so, of course, there's still a few questions bugging us. Is there really learning? Because very often when you come together, you kind of integrate the subjects. You often dilute the different disciplines, especially for mathematics. Mathematics fit into some of these things. And what does it really mean for my discipline? I mean, if I'm a math teacher, I want to make sure that mathematics is taught. If I'm a science teacher, I want to make sure the science content is taught. And how about our daily lessons? Because very often when we do this kind of lessons, these kind of lessons are very interesting, they are very engaging, but they take time to do. And so they don't happen every day, right? They happen once in a while. But if they only happen once in a while, what about our other daily lessons? So for that, I thought it's useful to think about the 4 phases of a discipline. Whether you're a mathematics teacher or a science teacher or a technology teacher or even a humanities teacher, these 4 phases might be useful for us to consider. In fact, they are useful for us to think about what exactly are we teaching to the students. And very often, we are only thinking about the content. And Keith Delvin in a NCTM yearbook in 2000 kind of suggested that when we teach our students, we are actually showing them the 4 phases of mathematics. And the first phase is actually mathematics as computation, formal reasoning, and problem solving, or more generally, the content of mathematics. And that's the most common phase that we present to our students. But mathematics also have other ideas, right? Mathematics is about applications and how mathematics can be used to solve problems in the real world. And that's the purpose of learning mathematics. I mean, one of the purpose of learning mathematics is to solve problems. And so these 2 phases are generally quite well known to the students. This is another aspect of mathematics that is not very well taught. There's mathematics as a way of knowing, as a way of thinking. Here we are seeing the world through the lens of mathematics, and even to think about how we come to know what we know in mathematics. So it involves a different kind of processes in mathematics. The way we reason in mathematics, the way we discover new ideas in mathematics, and the way we look at different aspects of the world. So for example, in statistics or in the real world, when we look at data, we look at data from the perspective of probability and statistics. When we look at, changes in the real world, we can see them from the perspective of calculus or even differential equation. When we look at the real world, we might want to think about quantity, and that leads to things like arithmetic and so forth. So you see, mathematics is a way of knowing the world. And very often we don't emphasize this part of the subject. Last but not least is mathematics as a creative medium. In other words, we use mathematics to create new ideas. We use mathematics to communicate certain things. So things like diagrams, certain mathematical diagrams, certain mathematical genres such as proof. All these are useful ideas in mathematics. So there are at least 4 phases to a discipline. So for example, in mathematics, you can have the content, you can have the methods, you can have the purposes and the forms. And we wonder whether there are 4 phases of the other subjects. And indeed, I'm going to argue, yes. Science as, well, many of you are science teachers, you know what are the contents in science. But science, very naturally, can be applied to the different problems and your applications of science. And it is so hard not to see the application of science in our daily lives. But science as a way of knowing, science as inquiry, is a very common approach to learning science. And in fact, it is is one of the approaches of knowing about science. And so, are we doing enough of science inquiry in our science lessons? But science is also creative. And this creative aspect is often forgotten. I mean, you look at all the scientists who came up with new ideas, writing new communications in science, or even creating something in science. What about technology? Well, certainly, technology has its set of content and maybe the different programming languages. Applications of technology is immense. I mean, these are 2 phases that we often talk about. But then again, technology as a way of knowing. I mean, how do we know what we know? How do we use technology to solve problems? And that might be something related to computational thinking. Last but not least, technology as a creative medium. Look at all the apps and all the solutions that we have, all the technology solutions that we have. They are a result of people who are talented in using technology to create new apps, new programs that we can use. And again, in engineering, it is easy to think of engineering as a set of content to be taught. But definitely engineering can be applied to solve real-world problems. But engineering as a way of knowing, yeah, because the whole process of engineering involves this idea called design thinking. You're trying to figure out what the user wants to do, and then you design solutions. And when you design solutions, engineers often think in terms of a system. And the idea of system thinking is another way of knowing in engineering. And needless to say, engineering is a creative subject. You create new systems, you create new products, you create new ways of doing things. So the questions I want to leave to all of you are as follows. I mean, what kinds of learning do you engender in your own classrooms? Do you promote in your own classroom? What phases of your discipline do you engage your students in? Is it only the content? Or is it only the applications? Or are you beginning to explore how the 4 different phases of a discipline can be featured in the classroom? And so the lessons that I learned as a mathematics educator from working with people around integrated STEM is that I think we need to give a fuller picture of what it means to do STEM. In fact, we want to say what it means to do science alone, technology alone, engineering alone, mathematics alone, and STEM as a whole. The whole of STEM is definitely more than the sum of the individual parts. And of course, there are other aspects of a discipline that we did not talk about. For example, the effective component of a discipline. The idea of dispositions, the idea of attitudes towards our subjects. What kind of attitudes do we want to develop when students are learning mathematics? One immediate one I can think of is enjoyment, right? I enjoy doing mathematics because mathematics is fun. What about science? What about engineering? What about technology? Are there other aspects of our discipline that we need to present to the students? And I think habits of mind or dispositions are important because very often when students face a new problem that they have not seen before, they tend to falter, they tend to be frightened, and they are not able to carry on. So how do we encourage our students to develop habits of mind or dispositions through the teaching of our subjects? And do our students enjoy learning? So here are 5 things that we can do. How can we instill the joy of learning through not just the integrated STEM lessons, but our daily lessons? So first idea, I think, is to really lead the way. We need to be the change. If you want to change the way teaching and learning happens in your classroom, we ourselves must make the change. We need to make our thinking and our feeling as a teacher in our discipline visible to our students. Because students follow you as a teacher. They see us as models. And so if you don't like your subject, if you don't display the passion for a subject, the students will likewise not develop that passion. Idea 2, have a go at integrated STEM. While you cannot do STEM or integrated STEM activity every day in your classroom, you can definitely do a little bit of integrated STEM in different parts of the lesson. I mean, it may not be every day, but you can do when we are teaching some particular topics, if there's an opportunity to make connections to other subjects, that's where we can, do it. So there's only do or do not. There's no try. Just do it. Idea 3. We may not want to do integrated STEM every single day, but we can definitely try to show all the phases of our discipline every day. We can make the content of our discipline visible. And to do that, we need to design learning experiences for our students to experience all the 4 phases of our discipline and more. And here, I'm not saying that you are going to do this in one single lesson. In fact, you're going to do this over the entire year that you have with your students. And if every day you do, show a few, 1 or 2 different phases of your discipline, by the whole year, I'm sure you have shown your students the different phases of the discipline. Idea 4, we teach for connections. It is important to make connections within the same subject. Very often they don't see fractions as related to decimals, fractions as related to percentages, fractions as related to ratio. The question is, how can we support them to make these connections? But connections are not just within the subject. Sometimes we can make connections between subjects. A very classic example is, for example, when it comes to chemistry, students often have to do some chemical calculations. And when they do the chemical calculations, for some strange reasons, they forgot everything about mathematics that they have learned. Because, for example, this idea of mole concept in chemistry, it is basically just mathematics. It is just about simple ratio and proportion. But the students can't see those connections. And we as teachers need to be able to see our subject and discipline from different vantage points. Here I imagine ourselves as teachers, it's like hiking up a mountain. Teaching is like hiking up a mountain. And when you hike up a mountain, sometimes you may take a detour because there are different vantage points that you can enjoy the scenery from. And so the idea of teaching our discipline is also related to the idea of seeing how our discipline looks like from different points of views. Sometimes we look within the discipline, sometimes we look across the discipline. Idea 5 and the last idea, have fun and work hard. Learning is fun, but learning is also hard work. Very often we try to say that learning is fun, therefore learning is not hard. But learning is hard work. If you want to learn something, if you want to master something well, you need to put in hard work. But we can make the process less painful. There is this idea of, there's no joy without pain. If you have never experienced pain, you will not experience what is joy. Hard work or effort is to be celebrated. And very often, learning from failures should be celebrated as well. Likewise, learning from success is to be celebrated. Learn together and have fun together. If you want to go fast, you should go alone. But if you want to go far, we want to go together. So where do we start? I mean, I hope some of these ideas resonate with you, or some of these ideas, inspire you to want to become better teachers. Now, of course, the natural question that you have is, so what? So where do we start? And I like this particular quote from Asst a lot. And in essence, he's really saying that if there's one principle that will guide you in your teaching and learning, or that if there's one principle that will help you become better teachers, it is this. Know what the learner already knows, and then teach him accordingly. So likewise, I'm going to share this idea with you. Where do we start? How do we start improving ourselves as teachers? The answer is, start from where we are. Right now, this is how we are doing. We start from where we are, and then we improve slowly. And to improve slowly, we just do it. We have fun. We work together. We try out some new ideas. And then we learn together. And that's how we can all improve as teachers. So there's a need to think about our instruction so that our learner experience both challenge and success. And with that, I'm coming almost close to the end of the lecture, but I'm going to share with you the slides. And so, I hope you managed to get some of the ideas. But more importantly, as was mentioned just now, I'm part of STEM, which is a research center in STEM education at NIE, which is Singapore's only teacher training institution. And I have here the link where you can go over and download some useful resources, including lesson ideas, including the lesson plan that I showed you just now from the Thailand experience, as well as some of the articles that we have written. And so it leads me now to stop and maybe invite some questions from the audience. Thank you very much.
Okay, thank you very much, Professor. Wow. Thank you very much for giving us such an informative and interesting presentation about STEM. And also thank you for your ideas. Yeah, that's really good and insightful. Okay, so for all participants, ladies and gentlemen, now are the time for the questions and answer session. I would like to have 3 questions from participants. So please, if you want to ask the Professor Choy, you can raise your hand and ask directly, or you can also write down your question to our chat box.
Okay, I see some question in the chat. So
Okay.
I think so there's this question: does integrated STEM take more time when we applied it in the classroom? The answer is yes. It takes more time. Naturally, I mean, that's why it's challenging. It takes more time, but is it worth it? Is it worth the time? That's the more important question. Is it worth investing the time to do integrated STEM? And my answer is yes. You may invest more time at the beginning, but you may get more in the long run. And it not always translate to results, but it may translate to some of your students being inspired by your lesson to become scientists, technologists, engineers, or even mathematicians. And so that's the reason why I said you don't need to do integrated science in every lesson, but you can find an opportunity to do it, then do it. And in the real conditions, sometimes teachers need more time to handle their student and to manage the class. Otherwise, we have target that must be accomplished every week. That's really true. It's true in Indonesia. It's true in Singapore. It's true in Thailand. It's true everywhere in the world. I mean, our students are not saints. They are not like, wow, so nice. Not like all of you. Sit there and then you all can listen. Our students are not like that. Our students are, wow, in a class. Sometimes, for lack of better word, I describe them as monkeys. They are like monkeys in the class. Then how do we engage them in learning? Actually, one of the reasons why sometimes our students are difficult to handle is because they're not interested in our lesson. They're not interested in the content that we are doing. Or maybe they're not interested because the way we present the content is not interesting. I mean, you see the same student thinking about something else. The student put in effort. For example, computer games. I mean, look at the boys. When they look at the computer game, they can tell you all the different characters and their specifications of the character. Know what strength they have, what kind of skills, what kind of magic they can do. But you ask them what is 5 times 6, they look at you and they can't answer. So I think one of the ways of getting our students and beginning to handle our students or manage the class is really to slowly start enthusiasming them in the things that we are presenting. And I don't think it's easy. And I don't think it is going to be like one day and then you can change everything. But I think you can change it over time. And if teaching is so easy, right, then we'll be out of a job. Because you and I will be replaced by technology. Yeah. But it's precisely teaching is so challenging and so interesting. That's why we can continue to have it. Yeah, I hope that kind of answer that question. I think if someone raised their hand, Naila, I think.
Yeah, thank you, Professor Choy. Thank you very much. I think that's answer your question, Mr. Dimas. Thank you for the question. And next, maybe we have students here. Raise the hand. Okay, come on. You can ask directly to Professor.
Yes. Hello, Professor Choy. My name is Naila. I'm from majoring mathematics 2023A. There is something I want to ask about integrated system. But first, I really apologize if the question asked does not really relate with the material because so far I'm still trying to understand. So the question is how the role of technology can be utilized in creating a more interesting and meaningful learning experience for students, as we know that technology is growing so fast. And the question two is what challenges may be faced in implementing an integrated system in a learning environment, especially mathematics. Thank you, Prof.
Okay, can you repeat your second question?
Why, sir?
Your second question.
Second question. Can you repeat the second question?
What challenge may be faced in implementing an integrated system in learning environment, especially mathematics?
You are referring to what are the challenges, is it?
Yeah.
Okay. So let me start with the challenges, because challenges are always fun to think about for a mathematics education researcher.
Yes.
I think for mathematics in particular, science maybe not so difficult, but mathematics is always very challenging, because they always ask me, why should I learn this? And I think that's one of the challenges, that we sometimes as teachers also don't know why we are learning this. So for example, why must I learn how to prove trigonometric identities? No one is going to use the trigonometric identities in their real world. Why on earth are we doing that? Or even algebra, why are we learning algebra? But I think there's one aspect. That's why the four phases, I think, provide a good way to think about mathematics. Besides the content, there's also this idea of way of knowing, right? So sometimes we need to use this content to develop different ways of knowing about mathematics. And I think that's one way to overcome this challenge. How do I make connections? All these are challenges. But the four phases provide a way for us to think about this. The other thing is, problems are always fun. I mean, okay, maybe I don't know whether I plan to do this, but never mind, one of the things that I like to do in the mathematics classrooms is to use some tricks, and mathematics tricks are always quite nice to demonstrate, and sometimes an appropriate trick can actually lead on to learning. Now that's a topic for another day. If we have opportunity to share some ideas with you, maybe I will do that next time. But consider what makes mathematics interesting to you in the first place, and then use those ideas to reach out to students. With regard to your first question about technology, how do you use technology to improve maybe the learning experiences of our students? I have one warning and one suggestion. So my warning is an important one. A warning means try not to do it. The warning is, don't chase after every single technology. Actually, at the end of the day, it is not technology that makes learning fun. It is not technology that makes learning experiences engaging. Just like you said, technology change. You can never chase after it. It is actually the teacher. It is actually the pedagogy. It is the teacher that makes learning fun. It is the teacher that makes learning engaging. If the teacher is not interested to learn, if the teacher is not interested in the subject, even you have the best technology, I give you the interactive whiteboard, I give you, graphing calculators, I give you computers. Every student have computers. I give you free of charge. Every student have free computers. Learning may not take place. And if you just teach as what you used to do, even with all these technologies, you are not harnessing the potential of these technologies. And so the warning to everyone is, don't chase after technology. It's not the technology. It is the teacher. It is the pedagogy. The second thing is, okay, but are there technologies that we can use? I think there are. Start with it. There are so many apps now that you know of, and some of these apps are really good, one of the apps that I like for mathematics and science is definitely Desmos. If you have not explored Desmos yet, I think it is a very nice graphing software. Well, it is a graphing software. On its own, it's just a graphing software. But the question is, how can I, as a teacher, make graphing software or use graphing software as a way to think about mathematics as a way to explore ideas in mathematics, as a way to model situations in mathematics. So for example, they have certain measurements in real world and they put the photo there. And now with Desmos, you can just plot the points and, try to model an equation over that. And it can potentially make learning more interesting. But then again, it goes back to the first point. It is not the technology. It is the teacher. It is the pedagogy. Yeah, I hope I answered that two questions.
Okay, thank you, Professor Choy. So, is it answer your question, Naila? I think enough, yeah?
Enough, sir. Thank you.
Yeah, thank you very much, Naila, for the question. Professor, we have other questions on our chat box. The question came from Miss Evie. She asked, okay, I would like to ask a question. How to consider its potential for integrated STEM and mathematics education? However, there are significant differences between science and mathematics as learning areas. Okay, do you get the question, Professor?
Yes, I saw the question also in the chat. So,
okay.
So I think you asked a great question. I mean, it is true that there are significant differences between science and mathematics as learning areas. That's why we are not saying that science is mathematics. We are also not saying that science is technology. We are not saying that science is, engineering. Each of the disciplines have their own unique set of knowledge, methods, purpose, and forms.
Sorry?
Like the 4 phases that we talk about. Each subject has their own unique sense. But you see, there are certain ideas that can be used as an integrating mechanism. One of which is problem solving. Mathematics, problem solving. I mean, that's what we talk about, right? And if you think about science, one aspect of learning science is also problem solving, because you want to understand certain things in the world. You want to solve certain problems in the world. For example, you want to solve the problem of climate change in the world. That involves learning science. If you think about engineering, well, engineering is about solving problems, right? I mean, you want to design better solutions for mankind. Think of technology. Technology is also about solving problems. How can I design a technological solution for this? How can I write a program that help me to do this? So what I'm saying is, yes, it is true that different subjects have their own learning areas and there are significant differences in them. If not, they'll just be called one subject. But how do we kind of integrate them is to use the idea of integrating mechanisms such as problem solving. Because no matter whether you are doing science or mathematics, there are always problems to solve. And frankly speaking, the process of solving problem pretty much go through the same phases, right? You have to understand the problem. You have to, devise a plan. You have to carry out the plan, and then you need to review the plan and see whether the plan works. It's just like, if I have an argument with my wife, for example, I need to understand why my wife is angry with me. And then I need to devise a plan, or maybe buy roses or chocolates, then maybe I have to carry out the plan, buy chocolates and roses for my wife and see whether my wife is happy after that, so even a relationship problem like this can be solved, basically going through the same process. So yes, while the two disciplines are different, they are different learning areas, there are ways to integrate them. And problem solving is one way to integrate them. The other way to integrate them is similar to problem solving. That is the second mechanism, looking at solutions. And when you look at solutions, you realize the solutions to the real world problems are not always monodisciplinary. In other words, they don't just look at one discipline. And very often you need to expertise from different people to understand the solution. And I think that that's another great way to do. Another mechanism that you can use to integrate learning is through the user-centric approach. That means start from the user. If I'm interested in someone and I want to solve the problems that he's facing, that helps me to think about all the different things I can use to help solve the problem. So yes, the subjects are different, but there's ways to integrate them. However, I also want to say that while there's a potential to integrate, mathematics, science, technology, and engineering, I think we need to strike a balance also. We need to find a balance point between teaching the essential ideas of our discipline and at the same time provide time and space to explore connections. That's why it's not about doing this or that. It is about trying to find what works for us within the context that we of time constraint that we have. Yeah. I hope that kind of addressed that issue.
Yeah. Okay. Thank you, Professor Choy. I'm sorry, that question of were from Mas Hendra, yeah, Hendra Kartika, not from FE. Thank you very much for the questions. Thank you. Yeah, integrating math as a problem solving. Okay, thank you very much, Mr. Hendra Kartika, yeah, for the questions. Okay, maybe for all participants, do you have any questions? Okay, we have a question, Professor, from Ibu Niswati. Okay, come on, Ibu Niswati. It's yours.
Okay, thank you, Pak Dayat. Good afternoon, Professor Choy. I agree with you about the STEM to solve the problem. In our national curriculum in Indonesia, we have some suggestion to implement learning model. There are many kind of learning models in constructivism, but there are two suggestions for us. There are case method and team-based project. Is STEM can implement more appropriate with the case method or team-based project or project-based learning? Maybe it is my question. Thank you, Professor Choy.
Thanks, Niswati, for the question. Definitely, I think you can use team-based approach. You can use problem-based learning. You can use all these different constructivist approaches for integrated STEM. I think they are a good fit, right? So, and in fact, I'm happy that your national curriculum actually encourages teachers to think about integration, because increasingly the problems that our students are facing in the real world is no longer just a mathematics problem or a science problem or engineering problem. It is a multifaceted problem. And so I'm not surprised that your national curriculum is advocating for teachers to think about all these different approaches, all these different ways of looking at learning. And very often this constructivist way of looking at learning involves things like collaboration, because students need to learn how to work together. And remember, integrated STEM actually provides an opportunity for students to do that. So even in Singapore, it's the same. We recognize that there are issues with the kind of things that we're teaching our students. And so, even in our recent revisions of the curriculum, we have included some of these approaches as well. So every country in the world are going about the same direction. Perhaps only Russia, Russia will go somewhere else, but the rest of us are going in the same direction.
But we have a big challenge to implement it. Thank you very much, Prof. Choy.
Yeah. I think it's difficult, to implement. I don't think it's going to be easy. Yeah, like I said earlier on, that's why we have to do it in teams. I think I know that in Indonesia you all have PLC, you have a professional learning communities in some of the schools, and I think that's a good start because we don't need to solve all the problems at one go. Actually sometimes I think we are very greedy. We want to solve all the problems at one go. Just do once and then that's it. But we might want to think about starting from where we are. Yeah, solve one small problem and then be happy about it. Then we can continue to learn and be better. Yeah, I think somebody raised hand and Evie.
Okay, thank you.
Okay, so we have another question from Miss Effie. Yeah. Time is yours, Miss Effie. You can ask directly.
Okay, thank you so much for your time. Good afternoon, Professor Choy. I'm Effie Soaiba from Physics Department. Actually, I'm not from educational department. I'm from Physics, but as a lecturer, we have to learn about the how to give a good teaching from the student at all. And then in the idea of STEM, we know that connection is important between the teacher or lecturer and student, and then how we can as educator foster meaningful connection among the student while incorporating STEM, science, technology, engineering, and mathematics learning to enhance the overall education experience.
Maybe that's a difficult question. I will probably need 40 hours to do just one part. That's an entire education course for teachers. I mean that's one course for teachers. But I think you are already on the right track because you said you said you need to make connections between the content, the students, and the teacher.
Yes.
And that's precisely the heart of teaching. At the heart of teaching, if you want to be a good teacher, you will start thinking about the connections between the content, the teacher, and the students. That's natural. The question is, what kind of interactions? What kind of connections?
Okay.
And I think there are some big guiding principles that we can use. So I'm just going to share a few with you, with everybody. I think number one is about the content. We need to think about the content that we are teaching our students. So integrated STEM or any other approaches that you take, right, doesn't mean that there's a dilution of content. It doesn't mean that the content is diluted. In fact, teachers need more time to think about the content. Because I need to think about the content and modify or even present it in a way that our students can understand. Then straight away you have that connection between the content and the students. It is not about the contents that you understand. You are the teacher, you are the expert. Of course you understand a lot of things. To you, Newton's 3 laws of motion is nothing, or Einstein theory of relativity is nothing. But to the student, this is something new. They were trying to struggle with it. And so being able to package our understanding into a form that our students can access will already be one step closer to making that connection with the student around the content. So making connections with students doesn't mean that it is always just about relationship. I mean, relationship is definitely one of them, but it is also thinking about how to make the content more accessible to our students so that they are able to access that ideas. The other aspect that I've already spoken about is to really present, all the 4 phases of the subject. The moment you present all the 4 phases of subject, it will require you and me as a teacher to think about interactions, think about what we do in the classroom. What do we do in the classroom? Whatever we are doing now is the worst form. Lecture, tutorial is one of the worst uh, form of teaching because I say you listen. You know that's sometimes it's useful, but most of the time in the classroom, you want to say something, but you also want students to do something.
Yes.
So I think that's where you can think about interactions. Get the
Okay.
students to do something.
Mhm.
I mean, when you have experiments in science, wow, it's always more interesting than just talking about it, right? You know, when you have a chance to bring students out into the world, into the nature, into other parts of the campus, oh, they are always excited. You know, if you want to learn about the ecosystem, bring them to the ecosystem. If you can't bring them to the ecosystem, show them a very nice video clip of it. You know, or do something that you can do within your means. In Singapore schools, we do not have a lot of land. We do not have a lot of ecosystem. So what many schools do is in their school they have a school pond. They design the school pond as an ecosystem, you know, and use that as for their science lessons. So that's some of the things that we have. So when you start thinking about the content, how to make it easier for the students, or how do you make it accessible to the students, not easier. How do you make it accessible to the students? What do you want the students to do in your class? And then lastly, think about how do you want to assess your students? How do you know that your students learn? When you start thinking about these three big questions, you are beginning to think about the curriculum in the three phases: the content, the pedagogy, and then the assessment. Yeah. So yeah, hope that kind of clarify it. I think there's quite a few questions here on the chat.
Yes, Professor. Is it okay? We have a couple of questions. Okay. Okay, so Professor, the next question came from Michelle Rajasa from Mathematics Education. He asked about strategies and approaches can a math teacher employ to effectively engage and motivate students who have a strong aversion to mathematics, ultimately helping them develop a more positive attitude toward the subject.
Yeah. So, like I say again, this is definitely not an easy question to answer. One, especially if the students don't like the subject. I mean, you know, if they don't like the subject, the moment the mathematics teacher go in the classroom, wow, they all don't want to do anything. You know? And so it's not surprising. I don't think it's going to be an easy battle to win. And so you need to start from where they are, right? You know, so very often in my first mathematics lesson, I will play some games with them. And usually I will win in the games. I will win the games, or you know, or they will be surprised at, hey, what's happening here? So I played this with some very young children in a primary school. I can play this game with you too, you know. So maybe I invite Michelle, is it Michelle? Where are you, Michelle? You can unmute yourself and play a game with you. Okay, it's a very easy game. Are you on, Michelle?
Michelle, hello.
Yes, hello.
Are you here? Oh, okay.
Okay. So, Michelle, you know how to count to 20, right? Can you count to 20?
Yes.
Okay.
Can you open your camera, Michelle?
Yes, yes.
Okay. Can you count to 20 for me?
What's that?
Okay, hold on for a while, because I'm in the hotel room. Hold on for me.
What? Okay, so for all participants, please wait a second. Sorry.
Okay.
You still in mute
Yeah.
mode. Oh, okay.
So, Michelle, can you count 1 to 20 for me?
Was it? Pardon.
Can
Sorry,
you
pardon.
count 1 to 20 for me?
Count.
1,
1,
2,
2,
1,
3.
2,
1, 2, 3.
1, 2,
3.
3. Next one.
Yes.
5.
4, 5.
Continue. You can continue, Michelle.
Yes.
Until 20. Can you do that?
Yes.
Okay. So if you can do that, then we can play this game. So I play this game with primary 1 students. I mean, some of them don't like mathematics, right? So and then one of the things they need to learn is to count to 20. So we're going to play a game. Let's count to 20. All right. And what is going to happen is I can count 1 number, 2 numbers, or 3 numbers. The first person to say 20 win. Do you want to start first, or do you want me to start first?
Yeah. Okay. You get the point, Michelle?
No, I didn't get the point.
I want to translate. Okay. I want to translate in bahasa, Profesor. So, berhitung ya, berhitung 1 sampai 20. Jadi minimal 1, bisa 2, bisa 3 dan bergantian. Yang mendapatkan angka 20 itulah yang menang. Is it clear?
Yes, clear.
Okay.
Okay.
So do you want to start first, or do you want me to start first?
Yeah. Want to start first? Michelle, or
Yes.
you want to start first?
Okay, Michelle, start first.
Yeah, come on, Michelle.
1,
2, 3, 4,
5, 6, 7,
8,
9, 10,
11, 12,
13, 14,
15, 16,
17, 18.
19, 20. Okay. Now you can already imagine in a class, right, of our young children, and they'll be very interesting. How come Mr. Choy always win this game? Okay, so actually the game is not just to interest the student. The game is to teach them problem solving skills. It's to teach them other aspects of mathematics. I mean, there are different things that you can use for different subjects, different topics in mathematics. So I think one of the things that you can do, to engage your students who have a strong aversion to mathematics, they really don't like mathematics, is to show them that mathematics can be fun. And even when you learn mathematics, it can be fun. And fun, but there's still learning. So like even in the game that we do, right, one of the things that I've done with the children is after they played the game several times, they realize that there are strategies that you can use to win the game. In fact, you can always win the game if you know what is the trick. And so the question now is find the trick and then explain why the trick works. And that's basically the whole idea of doing mathematics. Now, the game doesn't take too long to play, about 10 minutes, you can play the game several times and then students have a chance to discuss the ideas. That 10 minutes is probably more worthwhile than doing 10 minutes of exercise. The questions and do. So one thing that I would definitely ask you to think about is to think about some interesting things that you can use in mathematics. It can be a game, it can be a story, it can be something else. And when you do this from time to time, I'm not saying that you must do it every day, because if you want, again, we all have limited time and we can't do it every day. But if you do it from time to time, students will see mathematics not just as a dry subject, but there's other elements to it. Yeah. So I hope that gives you an idea of what you can do. Okay, I see.
Oh, so sorry. I'm still in mute mode.
Yeah, there's another question, I think, from
Yeah. It's our Vice Dean, Professor, Professor Roslyn Ekawati. Okay. she asked about the curriculum of STEM in higher education in Singapore.
Okay, so is it become one course or as a approach to teach several courses? All right, you Professor, you may be surprised that in Singapore we have no STEM curriculum. We don't have one subject called STEM. Okay. So, but we do have courses on integrated STEM. And usually it is part of the science teachers development. Yeah, so we do have some courses on integrated STEM. For teacher training in Singapore, at least, what happens is that the teachers are trained in their individual subjects, but there are courses like the integrated STEM one which the teachers can take. Now, however, I must say that our government is trying very hard to push for STEM. So as a result, we have also offered, okay, in fact, Meristem, many of the people in Meristem have offered courses on integrated STEM. So we do have certificates, additional certificates on integrated STEM. And these are courses that are offered to teachers after they have graduated. So there's this continual learning that takes place. And as a result of the continuous learning, there are courses that the teachers can take in order to become better. Okay, so that is one part of the answer to the question. The approach that we take to teach, STEM is at the school level at least, there are three approaches that we are taking. At the general level, that means for everybody, like I said, we try to introduce some interesting STEM activities to the students. Whether it is through our daily classroom, through small little things, or maybe through integrated STEM programs, or in some schools, they have this applied learning program, which allows them to do some of these STEM activities. And that's for everybody. But we also have a middle tier, which is selected students. Then these selected students may engage in more focused, integrated STEM activities such as robotics or other things, that they do. And then we also have the top, where the best students, those people who are really interested, to go even deeper, like doing research in STEM related areas. So the approach is a multi-tier one. That means we want everyone to enjoy STEM to some extent. Don't need to be expert, but just enjoy. It's like the math game that I play with everybody. It can be enjoyed by everyone.
Yeah.
Then we have some middle tier where students want to develop more. They have a choice to develop more, and students who are at the apex, that means they are really talented in STEM related areas. We give them the opportunity to be very good at it. So I think it is a multi-pronged approach that we are taking to try to develop STEM expertise in Singapore.
Yeah.
I hope that answered your question.
Thank you, Prof. Yeah, I believe because we have several students, they are interested to have research in STEM, from science department. And that's why I'm asking about this. We also think of the possibility to have like a course for integrated STEM because we are in the Faculty of Mathematics and Natural Sciences.
Yeah, that's a natural fit,
Yeah.
You have a Department of Mathematics and Natural Sciences. That's like, most like invitation to get people to do integrated STEM.
Yeah.
When you have experts in the university to do that.
Yeah, thank you.
In fact, if you are interested, we are offering some of these courses online next year. So when they are offered online, I can drop you an email and let you know that we are offering some of these courses, and I think there are special rates for countries in ASEAN.
Yeah.
So
Professor, our faculty, we are already international class program and already international accredited. So some of our students, they need to have also possibility to go abroad for like having a course maybe in NIE to your university, and also we also welcome your student to our campus.
yes, we will definitely want our students to go over and learn from their teachers as well. Yeah.
Okay, thank you.
Okay, thank you very much, Professor Roslyn Ekawati. So, Professor, thank you. And actually, I have a question also because we are in the same interest, STEM education, and also I'm working on mathematical modeling. So I have several questions, but I think because limited time, maybe I only want to ask you one question. Is it okay, Professor?
Yeah, go ahead.
Okay, so how about the problem, Professor? Because in mathematical modeling, also we have a cyclical process of problem solving. Begin with understanding the equation until validating, interpreting, and also exposing the solution. And I think quite similar. And mathematical modeling and STEM also have relationship, I think. And it's several articles that refer about that. And my question, on the one is about the problem, because in the first instructional framework of you, it's called about problem-centric STEM. And how to choose a problem, because sometimes I have idea to design a problem that I think it is suitable or not for STEM education. So do you have any framework how to choose a problem, and what guidance or requirement of the problem that's suitable with STEM education?
Yeah, I think that's an excellent question. But you are absolutely right. Modeling is such a useful way to do integration of mathematics. So when we look at many of the real world problems, a lot of students straight away go to science. They straight away think of science as a way to find solutions to the problem. But they forgot that actually mathematics offer modeling. Mathematical modeling is an excellent way to look at the same problem from the mathematics point of view. So what kind of problems? How do you choose a problem? That depends quite a lot on what you are trying to achieve. There are some characteristics of problems that lend themselves to integrated STEM. So one of the characteristics of such a problem is that it must involve more than one discipline. Because if it's only one discipline, then there's no need to do integration. Your integration will be very surface, very superficial. So it has to be more than one discipline, and usually it is a problem that we do not know the solution to, or at least we don't know immediately the solution to. I mean, it's not obvious. At least not obvious to the students, then it probably involves them, actively trying to seek out the solution, or at least have a chance for them to approach the problem from multiple perspectives. And probably a little bit more multiple solution kind of thing. That means there's no one right answer. So if you can find a problem like this, that will be really good. In fact, sometimes you don't need to look too far. Sometimes the problem is right there in your face. So we have a few examples here. I think one of the examples that one of our Thai schools do, so the Thailand schools, they did this. They realized that their school have a lot of pigeons. The pigeons, and then the pigeons pose a lot of health problems because the pigeons are there's so many, the droppings are everywhere. So then comes the question, right? How do you control the population of the pigeons? Well, then that requires us to understand the pigeon population, right? I mean, estimate the pigeon population, or that itself is a nice modeling question.
Yeah.
And then you may want to think about, then it really requires a little bit of science to know a little bit more about pigeons, their habits, their life, their life cycle, the the ecosystem, and then they need to figure out where the pigeons are, why the pigeons are there, what. So you begin to see that actually you don't need to look too hard for a problem. Sometimes the problem is already there. It's just that now, okay, I want to look at this problem from the science point of view, and that's not good enough to solve the problem. I need to look at the problem from the mathematics point of view. Oh, I need to know where they are, how many pigeons are there, and so forth. The other one that is quite useful to think about are diseases. You see, the last COVID-19 is such a good opportunity for learning modeling.
Yeah.
With diseases, it's always it's almost a natural invitation. There are some problems that are more open-ended and not immediately, seen as mathematics or science. So, for example, in Singapore, we have an aging population. So the population is becoming older. And then one of the things that, we begin to think about is how do we design a retirement village, where the old folks can come together and live. Now, that kind of problem is so open, but within that problem, there are smaller problems that are important. So, for example, one of the problems that I encounter is the old people, the elderly, needs more time to cross the road. So they need more time to cross the road. So the question is, how long should the traffic light be for the old folks to cross the road? Because the traffic light, if it's too short, they cannot finish crossing the road. If it's too long, then the cars are going to pile up, and there's going to be traffic jam. Then that invites a modeling thing, can I do a, stoichiometric, stochastic modeling of this
Deterministic
situation?
and stochastic.
Yeah, either using queuing theory or whatever, you want to do to kind of model this situation and then think about technological solutions for it.
Yeah.
When there's no, so you can start to think about some of these problems that are closer to where the students are, and sometimes it's about being a bit more alert, to some of the possibilities. Yeah. But indeed, if you given your background in applied mathematics, this is almost like a gift to you, You can find a lot of these kind of problems and then make it into a form that the students can try. We are not expecting them to solve the problem completely. We are expecting them to have a go at the problem. And using whatever they have learned in terms of mathematics, science, or engineering, or technology to try and have a go at the problem. And to develop maybe what we call prototype solutions. They are not the solutions yet, but they are prototypes. And so the schools, when they were dealing with the pigeon problem, they developed a prototype of a kind of trap, for the pigeons, to scare the pigeons away, so that they move to somewhere else. Of course, that's like transferring the problem to somewhere else, but it helped to solve part of the problem. Yeah.
Okay, thank you, Professor. I think all participants here and also me have many questions also for you, but because limited time, I have to close this question and answer session. So thank you very much, Professor, for your answer of the question. And okay, so for all participants, I think that's all for question and answer session. And ladies and gentlemen, finally, we come to the end of this guest lecture session. Thank you very much for you, Professor Choy. And before closing the session, I want to draw conclusion from what the speaker said or from Professor Choy said. So first about the STEM, the joyful learning through integrated STEM. First, it's challenging to design. And I think also it's not individual. So do collaboration, Professor. Yeah, not only Da Vinci teacher, you say there, but Da Vinci team. So do collaboration and make your own design of STEM education. And also, Professor here proposed the instructional framework of STEM. First, problem-centered STEM, solution-centered STEM, and user-centric STEM. Yeah, and the last one, he also proposed the idea. Here, first one, we have lead the way, and then the second one have go at integrated STEM. Third, show all phases, yeah, be a content, method, form, and purposes. And then four, teach for connection. And the last one, have fun and working hard. Yeah. And yeah, I think that's all. And the interesting sentence that I really admire is, if you want to go fast, go alone. And if you want to go far, go together. That's really good sentence from you, Mr. Choy. Thank you very much for your kindness. Okay, I think that's all for this session. Okay, Professor, on behalf of the committee, as an appreciation, we would like to award you a token of appreciation. So I would like to invite Vice Dean 1, Professor Roslina Ekawati. Hello, Professor.
Yes, Adayat.
Okay, thank you. So, committee, please, can you show the token of appreciation?
Professor, on behalf of our institution, we would like to please give the token of appreciation for you. With hope that we can meet offline sometime in the
Yes.
future. We hope you maybe if you come to Indonesia, just let us know so we can meet on offline. Thank you.
Thank you very much for inviting me, and I'm really happy and honored to be here, and I'm really very impressed by all of you spending your Sunday afternoon here listening to me, and I look forward to opportunities to see all of you again, and maybe do this maybe in face-to-face manner. Yeah.
Yep. Thank you so much.
And welcome to Singapore as well.
I have been in NIE. Yeah, with
Yes.
cooperation with Head Foundation.
So next time, if you drop by NIE, just let me know. Then I'll be happy.
Okay.
Yeah.
Okay. Thank you, Professor.
Okay, thank you very much, Professor Ekawati and Professor Choy. And okay, I would like to thank you also for all participants, for your participation. Thank you very much. And last sentence for all of you, see you in our next guest lecture session. Okay, Assalamualaikum warahmatullahi wabarakatuh. I will return this session to Master of Ceremony. Bu Niswa?
Okay, waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Dayat. Ladies and gentlemen, please give applause for our great keynote speaker and moderator for their incredible performance today. Thank you, Pak Dayat, for bringing us to a productive discussion today. Thank you to Assistant Professor Choy Heng. Thank you for the fantastic content you shared with us. And thanks to the participant for the tremendous dialogue. Well, ladies and gentlemen, this is the end of our session. On behalf of the guest lecture committee, thank you for joining us today. Forgive us when there are some mistakes. We look forward to seeing you at the next guest lecture, even in the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi
warahmatullahi
wabarakatuh. Prof. Choy.
Profesor.
Thank you, Prof. Choy. Thank you, Pak Dayat.
Thank you,
everyone.
Thank you all.
Thank you, Professor.
Thank you. Bye-bye.
Bye-bye.
Associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for